So I hope that everyone doubt is clear, students. Okay, everyone has cleared that doubt. Please reply me.
Yes, sir.
Yes, sir.
I've given the replies of many questions which you people have asked me. And now it's time to proceed to our lecture for today's, that is time displacement graph. This is our topic according to our syllabus of chapter 3, that is motion in a straight line. So we'll be talking about time displacement graph, and here you can see on the board, you can see that I have plotted one table according to this time parameter and displacement parameter. I have plotted one table here that shows the variation of time with respect to displacement. Okay, so why I'm writing the time displacement here? Why I'm not writing displacement time graph here? Okay, this is a question in front of everybody mind. Okay, this may arise. So I just want to write that why I'm mentioning the time and displacement, because if I'm mentioning the time, because then the time parameter should be represented horizontally, and similarly the displacement parameter, which is coming afterward that of the time word, comes in the vertical direction. Okay, so first we need to understand that if such type of the sentence has been given to us, so we need to plot the time parameter along the horizontal axis and displacement parameter along the vertical axis. Okay, so let's plot down the reading which is given here. Okay, according to the table, the values which are given here, let us plot it out. So in time, initially it is what 0.0, and after that we are having 1 second. Time is in seconds. Okay, it is having 2 seconds, 2.0. It is having 3 seconds, 3.0, 4 seconds, and finally 5 seconds, like this. And corresponding to this displacement at 0, the displacement is 0. Okay, so no need to write here the value of 0. And at 1 second the value is 20. And at 1 second the value is how much? 20. Okay. Again 40, 60, 80, and 100. Like this. The values are given corresponding to different time. And one thing what you can see from here, that I'll be plotting the graph. I'll be plotting the graph in which we can see in one definite time interval. Okay, 0 to 1 the time interval is how much? Time interval is 1 second. 1 to 2 the time interval is how much? Time interval is 1 second. Similarly, 2 to 3 the time interval is how much? Time interval is 1 second. So here, according to my observation, the time interval is fixed. Okay, and corresponding to this fixed time interval of delta t, 1 second. Okay, and having a rate of change in the velocity or rate of increment in the velocity. Okay, rate of increment in the velocity you can see corresponding to this, corresponding to 0 to 1 second. In between 0 to 1 second, our body has moved from 0 to 20. Again, now 1 to 2 second, again our body is transversing 20 meters of distance. That means the increment in the distance or displacement parameter is 20 meters. Okay, here also the increment is how much? 20 meters. Here also the increment is how much? 20 meters. In every case, corresponding to this fixed time interval of 1 second, I am getting a fixed what? Increment in the displacement. Okay, so what can I conclude? That a body has some velocity, as I told you in my last lecture, that if this formula is time is given and if displacement is given, then you will be applying the formula of displacement in terms of velocity and time. Okay, like this. Displacement is equals to velocity upon what? Time. This is what we can write. Okay, and once I told you, as you can go, that if speed is equal to distance upon time, and we last time we were talking about distance and time parameter. So if we are knowing the distance and time parameter, so we were calculating the speed. In the same way, here if we are knowing the distance parameter and if we are knowing the time parameter, then what we can calculate?
Velocity.
Velocity we can calculate. And according to this case, if the rate of change of velocity is constant, okay, according to our graph, what we are having, the rate of change in velocity is what? Constant. Or one can say the rate of increment in displacement is what? Constant. Okay, this also we can say. So this is completely the case of what? Uniform motion. Okay, this is the completely the case of what? This is the case of uniform motion, and according to my hypothesis, according to my syllabus, we are talking about uniform motion in a straight line. Okay, so this what I am assuming here, that I am having the uniform motion in a straight line which our body is doing. So according to this we are having displacement and time. So in this graph, after plotting these two parameters, what we'll be getting? We'll be getting the velocity. So somewhat, if we join like this these 2 points, then we obtain a straight line like this. Okay, you people are well aware from class 9 only. What happened in this case, we will be plotting and we will be getting what? A straight line corresponding to these points. If we match this point like this. If we match this point like this. So we will be getting what? We will be getting something in straight line. Okay, in the form of straight line. Is it clear? Till here everything is clear?
Yes, sir.
Yes, sir.
So let's see what else can be concluded here. Okay, since we know that if displacement and time is given to us, then according to this formula we will be calculating what velocity. So what is velocity in this case? Velocity in this type of the graph, in time displacement graph, since we are studying time displacement graph, velocity in this case will be the slope of this line. Okay, velocity will be the slope of this line with respect to this time axis. Okay, so here what else we can conclude? Velocity is what? Velocity is the slope of the line obtained. Okay, obtained. Velocity is the slope of the line which is obtained with respect to what? With respect to time axis. Okay, with respect to time axis. Okay, this you can conclude from here. And what is a slope? If someone asks you that what is slope, that how you can say that this is slope, and if you are saying that this is slope, then what do you mean by saying this term slope? What do you mean by saying this term slope? That what is slope?
The tan theta.
Tan theta. Very good, very good. Clear term of mathematics. So if we have been asked to calculate the slope of this line with respect to the horizontal axis, then what we do? We make a triangle. Okay, how will we making a triangle? If we are bounded to calculate the slope in specific time interval. Okay, if we are bounded to calculate the slope in specific time interval, for example, if we have been asked to do, or we have been asked to calculate the slope in time interval 0 to 2 seconds. Okay, let us assume that if we have been asked to calculate the slope in between 0 to 2 seconds, that means we need to bound this like this. Like this we need to bound. Am I right? Okay. So if we are bounding ourselves like this, then corresponding to this, okay, 2 seconds. So if we are bounding ourselves from 0 to 2 seconds, that means we need to draw what? Like this, something like this. Okay, and corresponding to this 2 seconds, what is the displacement a body has covered? A displacement body has covered of 40 meters. With 40 meters. You can see according to the table, according to this table. Okay. In between 0 to 20 seconds, how much body has covered? 0 to 40 seconds. So if someone asks you to calculate the velocity, okay, if someone asks you to calculate what? Velocity, because this line will be giving what? Velocity. Then velocity, what I told you, that velocity is the slope of the line obtained with respect to time. So what will be the velocity in this case? Tan theta is what? If we have considered this triangle, then what will be tan theta? This will be theta angle with respect to time axis because I am calculating. So what will be tan theta in this case? If I name this triangle, let us suppose that this is A, this is O, and this is A, this is B. What will be tan theta in this case? Anyone? Anyone?
Sir, AB by OB.
Yeah, it will be perpendicular upon base. Okay. Tan theta is equal to what? Perpendicular upon AB upon what? AB upon OB. So by knowing the value of AB, by knowing the value of AB, by knowing the value of OB, we can calculate what is the value of tan theta, and that is equal to what? B. Okay, B from where to where? From 0 to 2 seconds. Always remember, according to our condition. According to our condition, I am writing it. Okay. From 0 to what? B is what? From 0 to 2 seconds of time. Okay. So this is the value of B, and how much it comes out to be according to our data? How much it will be according to our data? B will be equal to how much? AB is how much? AB is how much?
Sorry.
AB is 40. Okay, this AB, which is equal to this. If we are drawing a horizontal line like this, so this length will be equal to this. Am I right? Am I right?
Yes.
So AB is equal to 40. And what will be OB? OB is how much along this time axis? 0 to 2 second angle. Okay, so delta T will be how much? 2. 2 minus 0 will be 2. Okay, so from here the value comes out to be 2 meter per second, which is the required value of V according to the question which I am asking you. Okay, so in this way you will be solving the question which is related to what? Time displacement graph. Okay, so start writing this, and after writing this, please let me know. And after that, we'll be discussing about some more properties in this time interval graph. Okay. Is there still any doubt? Is there still any doubt?
No, sir.
Okay. Our first topic will be in this time displacement graph. After studying all those things about time displacement graph, we'll be studying about determination of velocity in time displacement graph. Okay, that we have talked. In our graph. But after that also I am writing it here in a proper way. So what we can write, you can write down in your notes also in the same way. Okay. So what we have talked, the slope which we are getting, the line which we are getting about the motion in case of velocity time graph, that was giving us the velocity. Okay, the slope which we are talking about in case of time displacement graph, that was giving the velocity of a body. Okay, that shows the velocity of a body, and we talked about the slope also. Okay, in terms of tan theta, we have represented that slope, and it comes out to be perpendicular upon base. So for any arbitrary value, if you have been given, then you can easily calculate that what is the value of the velocity. Okay, now so we can write that if a straight line is coming, okay, if a straight line is there in time displacement graph, TD graph. So that line, the slope of that line, okay? So the slope of that line with respect to horizontal axis, okay, with respect to horizontal axis or time axis, one can say, gives the value of velocity. Gives the value of velocity. This we have discussed. Okay. So what we can write, the velocity corresponding to a fixed time interval we can write. So that will be what? Displacement upon time. So you can give the example of the previous graph which we have drawn. Okay. You can give the example of this graph. You can draw a graph again and you can show the straight line motion like this, and you can draw the time axis, you can draw the d axis like this, and corresponding to the fixed time interval. Okay, let us suppose that I am assuming the time interval t1 and t2 minus t1, the time interval I am including. Okay, and corresponding to this there are certain displacement. Name this displacement as s1, this displacement as s1, and name this displacement as s2 with respect to origin. Okay, so how you can write the velocity, or how you can determine the slope in this case? What will be the value of slope? So slope, what you need to draw? You are being asked to calculate the slope in between time t2 and t1. So in between time t2 and t1, what will be the triangle in this case? What will be the triangle for velocity? This will be the triangle. This orange part will be the triangle.
So theta will be same.
Yeah.
So theta will be same always.
Theta will be same because it is the case of uniform motion, that in which the velocity is increasing with a uniform rate. Okay, so theta will be same. So theta which will be here, theta will here will also be equal to that theta only. Okay, so corresponding to this time interval, I am talking about certain displacement. Okay, so net displacement in time t1 time, a body has transversing a distance of s1. Then in t2 time, body is transversing the displacement of s2. So what will be the net displacement corresponding to this time interval? How much? S2
minus S1.
S2 minus S1. So this distance will be S2 minus S1. So this will be how much? S2 minus S1. This will also be S2 minus S1. And this will be what? T2 minus T1. Okay? This will be
T2 minus T1.
Okay? So according to this, you can plot here S2 minus S1, you can write like this. Upon T2 minus T1. Like this, we will be writing about the slope, that is perpendicular component upon base of this triangle. Okay? So now what you can write? You can write it as delta S upon delta T. Okay? If someone asks you about the instantaneous velocity, then in this case, what you will apply? You will apply for instantaneous what? Limits delta T tends to what? 0. And in this case, ds upon dt. Because for instantaneous we use d term. I told you last time. Okay, but here no need to talk about instantaneous stuff right now. So this will be the velocity determination case. Now, what is the second point? Second point is greater is the slope. Okay, greater the value of the slope, greater will be the velocity. What I mean to say by saying this, let's see. Greater the slope, greater will be the velocity. Greater the slope, greater will be the velocity also. What I mean to say by saying this, let's see. If two types of the graph have been given, okay? If two types of the graph have been given to you like this, and here is one graph like this. This is same displacement time graph we are talking about. Displacement time graph. Okay, this is time parameter and this is displacement. So if we are talking about the graph and here shows the motion of two bodies according to this graph. Let this body be A, let this body be B. Okay, here are the motion of the two bodies. The velocity is increasing with uniform rate, with definite rate. So if someone asks me that in definite time interval, always understand this. Okay, if you have been asked to calculate anything, then the time interval will be bounded for it in graphical methods. So in definite time interval, let us assume that he has given the time interval of t1 starting from 0. This is 0. So he has given the time interval of delta t should be t1. That means we need to bound our system, the motion of this particle also and the motion of this body also. Okay, so it has been bounded till t1 time on the time axis. Okay, we have been bounded till t1 time from 0 to t1. So now someone asked us to compare in these two things, that which body has more velocity. Which body has more velocity. So what we'll be doing, we'll be taking this triangle. Okay, let this triangle be, let this be point M. We'll be taking this triangle. Let me use the other color. Corresponding to the first body and corresponding to the second body, let this be the triangle. Okay. Okay, you can see these two triangles. Let this point be P. So here is one triangle OPM and another triangle is what? OBM. That shows what? That shows, that will give the extent of the velocity. That will give the extent of the velocity. So, what will be the velocity of the two bodies in this fixed time interval? You can see that this length is much greater than dp is what? dp is greater than what? pm. Okay, dp is greater than pm. Is it okay? Are you getting it? People, are you getting it?
Yes, sir.
So less than over, no?
Is greater than what? pm. And this parameter is fixed for both the triangles. For both the triangles, this parameter is fixed. OM is fixed. So if we want to calculate if this is our body, first body, if this is the motion of the first body and this is the motion of second body, let us assume. Okay, this shows the motion of second body, this shows the motion of first body. So what will be the value of tan theta? Here there will be theta 1, here there will be theta 2. This will be theta 1 for first body and this will be theta 2 for second body. That's what I am assuming here. Okay, so what will be the value of tan theta 1? Tan theta 1 for this triangle POM. Okay, for triangle POM, that is smaller triangle. PM upon OM. PM upon OM. That will give the velocity V1. This will give the velocity V1 of first body. Similarly, tan theta 2 कितना हो जाएगा? Perpendicular for this triangle, for big triangle, upon base. BM upon OM. Okay. So from these two equations, from these two lines, this will give V2, the velocity of second body. So from these two things, what will have which quantity will have greater value? Tan theta 1 will have the greater value or tan theta 2 will have the greater value? Come on, tell me.
The tan theta 2.
tan theta will have a greater value. Okay, because here we have written that Bm is equals to what? Bm is equals to what? Pm. That's what we have written here. This entire length is greater than this small length. Okay, according to this condition. So what we can say that this slope is what? Greater. Tan theta 2 is what? Tan theta 2 is greater than what? Tan theta 1. That means greater the slope. Okay, because I fixed the time interval for both the bodies. So with respect to for first body, the slope is what? Less, and for second body, the slope is more, corresponding to this fixed time interval. That's why I written here that greater the slope, greater will be what? Velocity. I hope that till here it is clear.
Yes, sir.
So what we can say, we can conclude here that V2 in this case is what? Greater than V2 is greater than 1. That velocity of second body is greater than the velocity of first body. Okay, you can show here that OA represent the motion of first body and OB represent the motion of second body. And according to that theory, you can write it like this in your short notes. Is it okay? Is it okay, everyone?
Yes, sir.
Okay. Based upon the today's studies, okay, based upon today's topic, write down one question, everyone. And the question says that just try it by your own self, and if you will not get the answer, then next day I will be explaining you. Okay, I'll be solving it. The question says that a man walks on a straight road. Write it down fast. A man walks on a straight road from his home to market. From his home to market. .5 kilometer away. 2.5 kilometer away. With a speed of 5 kilometer per hour. With the speed of 5 kilometer per hour. Okay, full stop. Finding the market closed. Finding the market closed. He instantly turns and walk back with a speed of 75 kilometer per hour. With the speed of 75 kilometer per hour. Okay. What is the magnitude of average velocity? Comma, and average speed of a man over the time interval of first is 0 to 30 minutes. This is the time interval, and second is 0 to 40 minutes. Second is 0 to 40 minutes, and third is 0 to 50 minutes. This is the question. Okay, so just try it by your own self, and there will be some problem, then we will be solving it in the next class. Okay, I hope that everything is clear to everyone.
So find the market value close.
Finding the market closed. It is written there. Returns.
Yes, sir.
Okay. So I hope that everything is clear to everyone. Shall we leave?
Yes,
Yes, sir.
sir.
Okay.
Yes, sir.